Right. Welcome, everybody. We are going to go ahead and start in about 2 minutes, waiting for everybody to come in, or a minute or two. Okay. We're going to get going here. Hello and welcome to our safety webinar series. Thank you all for joining us today. My name is Lily Calderon, Director of Health and Safety Programs for the IU. Joining us today is Dave Donkin, MTEF South Regional Training and Safety Director, and Dan Flores, MTEF's North Central Regional Training and Safety Director. Unfortunately, Dave Wysocki, MTEF National Safety Director, could not join us today, but he does say hello and hopes that everyone enjoys today's webinar. It is also our pleasure to have with us guest speakers Gavin West and Dr. Bruce Lippy. Gavin West is Director of Nanomaterials Research for CPWR, the Center for Construction Research and Training, where he has worked for more than a decade to prevent occupational injuries and illnesses in construction. He is a graduate from the University of Virginia and has a master's degree in public health from George Washington University. Dr. Bruce Lippy is the president of Lippy Group, LLC. He is a certified industrial hygienist, certified safety professional, and a fellow of the American Industrial Hygiene Association. After retiring from his position at CPWR's Director of Safety Research, he has continued his work with CPWR's Nanomaterials research team as a consultant. Bruce's career has been dedicated to protecting workers. Thank you both for joining us. Together, they will present us with a brief overview on nanotechnology and nanomaterials, as well as giving us examples on how they are used in construction. They will discuss the exposure risks, health risks, and more importantly, how to work safely with nanomaterials. But before I hand it over to Gavin and Dr. Lippy, I want to go over some housekeeping items. This webinar is being recorded and will be available for viewing on our website, bacweb.org/safety. Materials shared from this presentation will also be on our website, or you can always contact me directly for them. We will hold a question and answer section at the conclusion of our presentation. You can use the Q&A box to submit questions throughout the presentation or at the conclusion. We will address them at the Q&A session. And as always, if you have any recommendations of future webinar topics, please feel free to submit them as well. Thank you again. And with that, we will begin. Gavin, Dr. Lippy, the floor is yours.
Thanks so much. I'm going to share my screen here.
Yeah, thanks.
Not a problem.
Get going. So here's our contact information. We'll have this again at the last slide. Encourage you to reach out. And as Lily mentioned, the topic today is going to be nanomaterials in construction. Not sure who here is familiar with CPWR, so we'll just give a quick brief intro to who we are and what we do. CPWR has served as the NIOSH National Construction Center since 1990. We're a nonprofit organization, and we were created by North America's Building Trades Unions, NABTU, which is an umbrella organization representing about 13 different international unions. And so we're federally funded, so all of the materials and resources that we generate are free. And I encourage you, if you haven't been to our website, this is our main website, www.cpwr.com. Check it out. There's a lot of resources there that you may be able to use in your work. And our mission is to reduce occupational injuries, illnesses, and fatalities in the construction industry. So Bruce and I work for our research program, which you see in the middle here is the National Construction Center. That's funded on a 5-year cycle through NIOSH. We're getting ready to hopefully put in another successful application. We also conduct medical screening of former DOE workers, construction workers who worked on the nuclear weapon sites across the country. And that's funded through the Department of Energy. And we do training as well. And the funding for that is through the Department of Labor, through OSHA, and as well as NIEHS, part of the NIH. And all these programs try to work together, create synergy, and feed off of one another, as you see here. Here's what we're going to cover today. After this session, you'll be able to explain nanotechnology using visual aids and familiar concepts. We'd like you to be able to list 3 ways that engineered nanomaterials are used in construction. We're going to focus on the bricklayers and allied crafts as well. And I'd like you to be able to discuss what we know about exposure risks as well as health risks. Importantly, be able to implement controls to minimize exposures. And we'll wrap up by talking about where you could find some resources to learn more about working safely with nanomaterials. So this will kind of help us keep track of where we are in the talk. We had those 5, and this will kind of orient us. So let's dive into this first objective in terms of what is nano? What is nanotechnology? If you go to this website, nano.gov, the definition there is science, engineering, and technology conducted at the size range of about 1 to 100 nanometers. So there's been a lot of advancements recently in technology that have enabled us to basically create new materials. And it's this tiny size range, 1 to 100 nanometers, that we're talking about. So I think most of us are familiar with a yardstick. The yard is roughly a meter. Think about cutting that into a billion sections. So a 1/1000th of a meter is a nanometer. You really need a really teeny tiny saw there. Here's another way to think of it. Earth is about 100 million times larger than a soccer ball. So that same ratio from the Earth to the soccer ball, that's how much bigger that soccer ball is than this type of nanoparticle called a buckyball. Here's one more example. This nanoparticle shown here is about 1 million times smaller than an ant. You need about 1 million ants to just do 1 lap around the Indy 500 racetrack, which is about 2.5 miles long. So what is an engineered nanomaterial? And you might see that abbreviated in some places in this presentation as ENM. It's an object that is 1 to 100 nanometers in at least one dimension. So that could be length or width, other dimension, created by human beings for some purpose. So, we're creating these. What you see here on this slide, these are all the same chemical compound, zinc oxide, but you see there's different shapes and sizes, and that enables different applications, and these are used in a wide variety of industries, in medicine as well, in the automotive sector, not just construction. And by changing, their shape and size, and other things, you can influence their properties and their applications, their desired benefits and used in products. But the flip side is, that can also influence their potential health effects. Welding generates fumes that contain nanoparticles. Are they engineered nanoparticles? Feel free to, if anybody wants to drop an answer in the chat, whether or not they're engineered, the nanoparticles in welding fumes. I can't see what folks are putting in the chat right now, but if you said no, that'll be correct. They're not engineered because they're not created for some purpose, right? They are in that same size range, and there are some similar concerns about the health effects of these really tiny particles, more traditionally called ultrafine particles, in that same size range. But it's really a byproduct of the process. So there's other terms like incidental or process generated, where these are just a byproduct of the work. They're not really something we're producing intentionally. And that's really what we're more focused on today. So can nanomaterials differ from larger forms of the same material? Let's take this example. Bulk gold, and the parent form of the material is yellow, we all know. It's non-magnetic, and it's inert. So if you take gold down to the nanoscale, and actually the colors can change depending on where you are in that size range. At around 10 nanometers, gold is red. Now it's magnetic, and it's also explosive. So you can have different properties, which is very interesting when you take materials down into this size range of the nanoscale. Surface area is another major difference. So we have this cube of gold here. It's 1 meter on each side. about a little over 3 feet, weighs about 43,000 pounds, and the surface area is about 64 square feet. So let's slice that up. Say we chop that up into these tiny cubes that are 1 nanometer on each side. So we still have the same amount of mass, right? The total amount of material hasn't changed, but what has changed is the surface area. So before, when it was 64 square feet, now we're talking about surface area about 2,500 square miles, about the size of the state of Delaware. And so what that means is, that material was essentially hidden, but now that surface area is available to react. So that, again, that has implications for their uses in products and applications in industry, but that also means, more area that was previously hidden for reacting inside the body. They can be more reactive. I'm going to pass it over to Bruce now.
Thanks, Gavin, and hello to everyone. I appreciate the opportunity to speak to you. So I'm going to talk about engineered nanomaterials in construction, and it'd be nice if you could be able to list 3 ways that they're being used. They're being used in a lot of different ways, but that's our objective number 2. Next slide, Gavin. Important message from our program. We've been doing this program now going on to our 10th year of research and training in nanomaterials. We've been tracking how nanomaterials are used in construction. And at this point, we're about 900 products that are on our inventory. And you can get to the inventory through Elkosh Nano, which is just www.nano.elkosh.org. This is all free, and we list these products, but we have to say that we're not positive about them containing nanomaterials for the most part. We have indications when we do the research that this may be. Gavin mentioned being photosensitive, being able to react that way. That's one of the indications that this might be a nano product. But there's 900 that we think may be nano. Next. I'm excited to say we're about to launch what's called a dashboard for nanomaterials. CPWR, I do say check it out, the main website. We've got so much good material, and we have dashboards which puts out data, but in ways you can work. You can do all kinds of adjustments to just get what you want to pull from data. With Nano, we have these pie charts. One talks about the number of products by nanomaterial, and I won't go over all this, but one of the things I really want to bring to your attention is the dark gray slice there, which is the largest slice, 38%, and it says undetermined chemistry. So there's a lot when we look at these products that we really can't say for sure what is in that. We just have an assumption from looking at the information that it may be a nanomaterial. But then you can see we see about 10% have polymers. Silica is one of the ingredients in these products, and this is a lot of times amorphous silica. It's not the crystalline silica that we worry about on construction causing lung cancer and other issues. This is amorphous, but still in the small range, as Gavin mentioned, it can be a problem as far as a health risk. And then there's also, I'm going to be talking about the dark rust red color. That's graphene, and that's going to be more and more seen because it's an incredibly useful material, and that's about 6.5% here. The other pie chart that's to the right on the screen is whether or not there's safety data sheets available. And what you see is about 50% do have some safety data sheet you can get right through our Elkosh Nano site, which is great. The other half is not accessible through Elkosh Nano, but there may be safety data sheets. It's just that the manufacturer doesn't want to put them out until you buy the product. So we're not saying that half don't have. We're saying that you're going to have to do a little digging or buy the product to actually get a safety data sheet. Still, but it's not good that we can only find half. That's not helpful. But then we also have the number of products by trade. And you can see concrete and cement masons out of the 900, there's 200 basically that are products that they may use. And brick masons, we have 52. And of course, there's others. There's a lot of minor uses of nano that will show up. But the message with this is that cement masons working in concrete and also brick masons do have products on the market now, commercially available, that you may be even using. So next slide, please, Gavin. We also put out this way, a number of products containing nanomaterials by trade. And you can see, again, the concrete cement masons, the largest block there in blue at the far left, brick masons. Also, I understand some of the members working with tile. And so that's in orange there, that red arrow. So it's a nice way you can adjust this however you want to get the information that you need. And it's a good thing to show other workers that if you're doing training, that they can access this tool. It's not available just yet, but by October, it'll be up and running. Next slide. And one of the things you can do is pull down a menu here, and you can see I've indicated brick mason there. And then you can look at the number of products and the specific materials that are in that. And unfortunately, again, the orange is undetermined chemistry, but polymers are a big thing. These are long chain organic compounds which have nanoparticles attached to them usually. Graphene is very big. You also see titanium dioxide. That's a material that NIOSH does have a recommended exposure limit for in nano. So that's an important material. Next slide, Gavin. Gavin produced this word cloud here that I think is pretty helpful. And this is manufacturers report using greater than 50 types of engineered nanomaterials in construction. So we found 50, but it all breaks down this way. This is how it's used. And you can see undetermined just jumps right out at you. So we don't know what's in it. And that's a really important message to take to the membership. But titanium's very big, silicon, carbon, you see graphene at the lower left, and polymers, which are very valuable. You can use them in all kinds of ways. So this is word cloud, I think, is helpful. Next, please. Well, let's talk about some specific products. And we're seeing a lot of sealants for masonry that potentially contain nano. This is a product called CaraPro, and this is right from their website. So this gentleman is using a wand here, and the process. And if you look to the right, this is a building in University of Houston at their campus, and they didn't do any pressure washing in 10 years. Doesn't say a whole lot about their maintenance, but you can see how dingy it is up top. And it was, had fungus and lichens growing. And then they used this cleaner, CaraPro masonry cleaner, and they pressure washed it. And then after that, 24 hours after, they sprayed this sealant on. It's called CaraPro single coat clear masonry sealant. So they put that on. The bottom picture is a year later, and you see it does a pretty nice job. That's one of the things that's important to stress with we're going to talk about health effects, but these products can make a huge difference. And they can actually save as far as energy and environmental issues. So they're going to be with us, and we need to figure out how to make the best of it. But notice this gentleman is working with absolutely no protection at all. And one of the things we found is that spraying of these materials can put the particles in the air. This is not the best way to go. Next, let's do I want to show you how effective this is. Can we do this is a little YouTube.
Meet Grammarly Go, your go-to solution for getting quality work.
We'll have to get rid of this ad, but I want you to see this water repellent material. They've put it onto this surface. I don't know if you have any products that you presently use that work this well, but I was impressed. All right, thanks. All right, let's get back to the slide. Thank you. Next slide. So here's a product called Nano 1000 Concrete and Stone Sealer. Again, another sealer. And this is a USA product. It's commercially available. And it says it uses nanotechnology, and pull up the next piece there, Gavin. It's easier to read. If you can just click on the next.
Sorry, Bruce. Yeah, gotcha.
Yeah, there we go. So this is the ad says Nano 1000 uses tiny molecules to bond to the surface to which it applies. Tiny is a pretty loose term, but because they use the word nanotechnology, as you see, reason for inclusion, that's our reason. We say we're putting this on our inventory because it uses the word nanotechnology, but that's part of it there. And also I would point out that it talks about a fluorochemical that is 9 to 12% mixed in with water. So this is a water-based material. But notice that it says CAS, the Chemical Abstract Service number, is a trade secret. So once again, there's a whole hell of a lot of fluorochemicals, and some of those are PFAS that are the forever chemicals in the environment. So we don't know what's in here, unfortunately. Next, please. I want to point out that these aren't just mom and pop shops. You know, Rust-Oleum. There's a lot of large brand name products that are putting nanomaterials in it. This is Sealcrete, and it's a lockdown material. It's a self-cross-linking epoxy floor bonding primer, and you know, we some of these will say there's a link there, SDS, TDS, safety data sheet, technical data sheet, technical info. But a lot of times, if you pull up that information, you still don't know what's in the nano size range. That's going to change with OSHA. We'll talk about that in a little bit. Okay, next, please. Here's another product that you might run into. It's called Hex Mortar. It contains graphene, and it's used in shotcrete. It's used in mortar and pumping applications, as you can see here. And this is one chemical. I'm looking at the product safety data sheet here, where they actually say, it's the blue arrow, that it includes graphene, which is terrific. It gives the CAS number for graphene. So that's good information. But what's interesting, it's using it in 0.5 to 5% in the product. OSHA says that if you have less than 1% by weight of material in your product, you don't have to list it on the safety data sheet unless it's a carcinogen. So, and then it gets down to 0.1. So because nanoparticles are light and sometimes they're not used as much, you know, it's a lot of times the discretion of the manufacturer whether they want to mention it at all. So that's a problem, and there may be some remedies coming. Next, please. I'm going to turn it back to Gavin. I appreciate your time.
Thanks a lot, Bruce.
Yep.
We're moving on to our third objective, and we're going to discuss what we know about exposure risks and health risks. The health risks of nanomaterials vary widely according to their structure and properties. So this slide I showed you earlier, right? This is all the same chemical compound, if you remember. It's zinc oxide. But, you know, as I mentioned, humans now have this ability to really manipulate matter at this nanoscale and do a lot of interesting things in terms of how we design particles and these materials. And as I mentioned, that changes their properties, their applications. But the concern is, you know, how does that affect how they interact with the body if when humans are exposed? So here's one example. Multi-walled carbon nanotubes have caused asbestos-like disease in lab animals. So that's where most of our knowledge of the health risks come from these. There have been many animal studies looking at cell culture models as well. And in this case, we have this carbon nanotube on the left, where this is an image showing it penetrating the pleura of the lung. So that's, you know, a similar disease mechanism to asbestos. And then here's a diagram of what it looks like on the right. It's, you know, these each one of those is an atom thick layer of carbon, which is essentially graphene, and then it's rolled up. They're rolled up onto each other into this tube. And it's a very stiff, rigid material. It's very, very strong. And so this is, when we talk about structure and properties, high aspect ratio nanomaterials, these kind of long, rigid fibers are one that we tend to be more concerned about. And that one has been studied to a great degree. What I will say, though, is human health studies are very challenging to conduct. It takes time in humans. There's a latency period between the exposure and when we see the disease, which could be 20, 30, 40 years of exposure before workers could possibly get sick. And there's other aspects in terms of ethics, in terms of, when you're working with animals, we'll dose animals and see the effects. You can't do that type of thing with humans, obviously. This was a review paper, and Paul Schulte was the lead author. He's recently retired, I believe, but he at one point was one of the co-directors of the NIOSH Nanotechnology Research Center. And the conclusion of this paper, they looked at all the human studies and epidemiological investigations available. And they said, in this state of uncertainty, precautionary controls for each engineered nanomaterial are warranted, while further study of potential health effects continues. So there are still question marks in terms of the human health risks. But we know enough that we should be taking precautions. So what are some of the characteristics of nanoparticles that are concerning? Their size, because they're so small, nanoparticles can deposit deep within the lungs and move to other organs where larger particles cannot. So down here in this diagram, you see the pulmonary alveoli and particles less than 2 microns. 2 microns is 2,000 nanometers. So we're talking much smaller with nano. They can get down to the alveoli of the lungs where the gas exchange occurs, and in some cases can enter the bloodstream and cross the blood-brain barrier in some cases where larger particles are unable to do so. The NIOSH recommended exposure limits, or RELs, are lower for nanomaterials versus larger forms of the same chemical. So what does a lower exposure limit tell you? Feel free, I don't know if folks can come off mute or if you can put answers in the chat, but feel free to do so. What does a lower exposure limit tell you? Again, I can't see the chat, but if anybody put this in, it would be correct. More hazardous materials have lower exposure limits. So the lower exposure limit, the more hazardous the material. And so that's worth noting that for these 3 recommended exposure limits, there's one for carbon nanotubes and nanofibers, which is very low. Silver nanomaterials and titanium dioxide, they're all lower than the parent form of the material, the kind of silver and titanium dioxide we're more used to seeing historically. And this is also worth noting is that there are no OSHA permissible exposure limits for any nanomaterials. OSHA does recommend an official guidance. You can check out this fact sheet, and we have the link here, following the NIOSH recommended exposure limits. So I mentioned there was those 3. And Bruce talked about just in construction, how many nanomaterials we've documented are being used. So we don't have exposure limits for most nanomaterials. So what should we do? This was a really good document, the technical report. It was really focused on exposure sampling for engineering nanomaterials. But NIOSH put this out last year and talked about what are the exposure monitoring program goals. One is to maintain exposures below the NIOSH recommended exposure limits. Another recommendation was that to minimize exposure to engineered nanomaterials without recommended exposure limits. So again, that's kind of going back to that review paper I said, where we're going to be on the safe side here because of what we know about these materials. So our earlier work focused on spraying and sanding of paints and coatings. We did these studies in a containment, in a environmentally controlled chamber. We use a variety of instruments. Those are particle counters you see in the bottom left there, where we can count particles in different size ranges. We also use more conventional industrial hygiene sampling methods using filter-based methods there. And of course, we try to partner with experts from the trade. So make sure we're doing things in a realistic way and safely. And you see that folks are wearing Tyvek suits, powered air purifying respirators. We're not exposing anybody as part of our research, making sure we're taking proper precautions. And one of the questions we want to answer is whether free, unbound nanoparticles are released during construction activities. So what our studies and most other studies have shown too is typically this is what we see. Here we see on the left these paint spray droplets with these white nanoparticles are kind of contained within the droplets there. And on the right, that's a piece of sanding debris. So after the paint dries and we sand it, those white colored nanoparticles, and these are electron microscopy images. So this is extremely high magnification. They tend to remain embedded within the material. And so that's important because that's the general expectation is that's going to pose less of a health risk than if these nanoparticles are free. And that's a lot of the toxicity studies have examined them in that form, kind of as they're produced, not added once they're added to the product. So that is a little difference there, a little nuanced difference. And we partnered with instructors from the International Masonry Institute to conduct a study at the National Training Center in Bowie, Maryland. It's a wonderful facility. We're really happy to be able to partner and work with great folks there. And I would like to give a big shout out and a thank you to everyone for sharing their expertise in making the study possible. So folks we worked with at the International Masonry Institute, Anthony DePerna gave us a tour, was setting us up with everything we needed. Dave Wysocki, who couldn't join today, was helping to make a lot of the arrangements. And we worked directly with Pete Cole, Ricky Frank, and Joe Pugliano on as I mentioned, we want to work with trade experts to make sure we're doing this in a realistic way that's occupationally relevant. We're doing things safely as well. And so you can see Joe is getting suited up here in this photo, getting the pumps hung up on him before we do some grinding on some of these slabs. And we also had colleagues, collaborators from NIOSH there. So the folks listed here all work in the NIOSH Health Effects Laboratory Division in Morgantown, West Virginia. And so 4 of them were on site when we were doing this sampling, and they're toxicologists primarily. Emily Lee is an industrial hygienist, but they would take the data, the measurements that we take, as well as actual samples, dust samples, and they would take slabs back and they would use those in their toxicity research, the type that I was talking about earlier, working with animals in the lab, cell cultures, to look at the potential health effects. So what we studied was a liquid admixture, and this was commercially available, and it contained graphene nanoplatelets. And those are used to increase the strength and durability of the concrete and the mortar. And so graphene, that's the same material that you roll up into those carbon nanotubes, but quite different from the health effects from what they've or toxicity from the study that's available. But it is this incredibly, graphene in its purest form is 1 atom thick sheet of carbon, and what you see sometimes more is multiple sheets. And the first thing we do is verify what's in the material. As Bruce said, you can't always rely on the information provided by the manufacturers. So here's Andreas, our microscopist. That's a light microscope where we're looking at the filter loading, but we would use an electron microscope to really look in there and characterize the material like you see there on the left. And we collected air samples during cutting, grinding, and tuck pointing, as you see here. So we looked at concrete and mortar with and without this engineered nanomaterial additive, and we also looked with and without exposure controls and engineering controls. And we were taking samples and using particle counters as well. And so I mentioned that question. We want to see if the material, what's coming off when you're doing this. Are you seeing some of the free nanomaterials? And we actually did find free unbound graphene more frequently than we expected. So that was one of the important findings, notable findings from that study, was we were seeing it come off as free particles. Thankfully, the good news was the engineering controls worked very well, and they reduced exposures to a level below which we could detect them. So they were below detectable levels. You can see we were using a wet saw there, local exhaust ventilation on the grinder and during tuck pointing activities. And in the bottom right, you can see that cloud of dust That's grinding without the controls. And again, you see this is on the bottom left, the dust being kicked up. And because that's not normally the way they do things, they teach workers and apprentices how to do things safely, which is great at the training center. But we did these very short duration samples to look at the worst case scenario, which we know this does happen sometimes, and out there in the real world. Unfortunately, controls aren't always used. So 1 minute of tuck pointing without the controls generated high levels of both respirable dust and elemental carbon in the breathing zone. And elemental carbon is what we're using as our marker for graphene. And so, the exposure limits for nanomaterials tend to be in the microgram range. So, like a whole order of magnitude, or orders of magnitude less than milligrams that we found here, 3 milligrams per meter cubed, which is quite high, especially because nanomaterials have very little mass, very little weight. But there is no benchmark, there is no exposure limit for graphene. But that was quite high with compared to what we were expecting. And you can see images of it here, and this is what we use to look at the chemistry of it. And then here I'm highlighting on the right is the conventional cement composite without the graphene, and here's when we were adding in the graphene to the mortar in this case. And the respirable dust with just 1 minute, it was 51 milligrams per meter cubed. And the OSHA PEL is a time-weighted average is 5, so it was 10 times higher. ACGIH is a little lower at 3 milligrams per meter cubed. Interestingly, with the graphene concrete, it was below the detectable limit here because these were short duration samples, so it was less than 23. And what that really told us was about the hardness of the material, which we really noticed. The graphene material was much harder. So the conventional one was softer, is actually kicking off more dust. Another thing we looked at was the noise levels. When you have a harder material, that can be higher decibels. So I'm going to hand it back over to Bruce for the fourth section.
Okay, thanks, Gavin. So we're going to talk about controls. As Gavin said, the good news is conventional controls used to control things on construction sites work for these little particles. And I'll go over some of that. Next slide, please. I hope you're all familiar with the hierarchy of controls. And, our research shows that exposure controls used in construction are effective for nanomaterials. And I got to say, I taught a graduate course at Hopkins and the School of Public Health on safety, and it was built all around the hierarchy of controls. And I really strongly believe in trying to follow these as much as possible and staying up as high as possible on the hierarchy, which I'm sure you're familiar with. In fact, I was an advisor to a national demolition company, and I tried to convince the president that when they had a plan for demo, that when they were going to drop down from any level to a lower level, that it had to be in writing so that they just weren't doing it willy-nilly. But at any rate, with nano, it's a little different in that elimination, physically removing the hazard, taking the nanomaterials out, gets rid of the exceptional properties that they bring. And also with substitution, there's not much substitution you can use in nano without, again, losing that product. So that they're a little problematic here. Engineering controls are where we can make a major difference. And of course, as they move down, there's also administrative controls. And finally, PPE that we'll talk about. So next slide, please. Off the bat, wet methods work. Ventilation is great and it really knocks it down, as Gavin showed you. But good old wet methods, that wet saw we used, huge reduction, of course. And even things like these trucks that are keeping roads wet. And bring up the next image. This is a sort of a jury-rigged wet method for jackhammers that the laborers came up with. It worked. It kept the dust down. So let's not forget what is our friend in control methods. Next, please. As we drop down to work practices in construction, we have this sort of unique problem of bystander exposure. this on the left is a gentleman spraying a coating on glass. There's lots of different coatings that you can get for glass that do all manner of things. And for instance, to take dirt away by every time it rains, it just washes it all completely off. But look on that picture, the gentleman has a respirator on. But if you look at the reflection in the glass, there's people behind him, and the one individual doesn't appear to be wearing a respirator. So they may be getting a shot when he's spraying this. Similarly, the individual on the right with the yellow paint is protected. He's got on respirator and a hard hat, but there are colleagues all around working that may be getting a hefty dose and not even paying attention to it. So we do have to worry about bystander exposure. Next, please. So PPE, I have this question here. Will respirators work against nanoparticles? We have a full face respirator here with a HEPA cartridge and same with a half face, high efficiency cartridges on there, plus some other organic protection. So can we get someone in the chat or just just raise your hand if you think respirators can work against these teeny particles?
2, 3, 4 people have raised their hands. 5.
Okay. All righty. Thanks. So next slide. The answer is yes. HEPA filters capture nanoparticles. And if you remember the definition for a high efficiency particulate air filter, it's 99.97% efficient against particles that are 0.3 micrometers in diameter. And so, that's 300 nanometers. That's above the definition we're talking about for nanoparticles, 1 to 100 nanometers. So the question is, why don't they blow through? And the answer is kind of with this cat with the styrofoam beads all over it. I would like to run this video because this is something that's misunderstood a lot. And so I'd like to show this. Thank you, Gavin.
Prior to March 2020, there's a good chance you didn't know what an N95 mask was, or at least didn't think about them unless you were doing a home repair project with lots of dust, or live in a part of the world with crazy pollution or wildfire smoke. And upon learning about them, you might think, like I did, that an N95 mask is basically a really fine strainer, a mesh of fibers with gaps too small for dust and other airborne particles to get through. A strainer filters out particles larger than its openings, but not particles smaller than its openings. So you'd expect that with a mask, after a certain point, small enough particles will sneak through. But this isn't how N95 masks work. The particles they filter are generally much smaller than the gaps between the fibers in the mask. What's more, an N95 mask is actually really good at filtering both the largest and smallest small particles. It's medium-sized small particles that are hardest for it to block. This isn't at all like a strainer, because N95s are much cleverer than strainers. The overarching goal of an N95 mask is instead to get an airborne particle to touch a fiber in the mask. Regardless of how big an airborne particle is, once it touches a fiber, it stays stuck to it and doesn't become airborne again. This isn't anything special about the fibers, but about the size of the particles. At a microscopic scale, everything is sticky because the weakly attractive force between molecules is more than strong enough to hold very small things in place. So you shouldn't think of N95 masks like a fine window screen that keeps insects of a certain size out. You should think of them more like a sticky spider web that can catch an insect of any size as long as it touches a strand. And so N95 masks use a bunch of different clever physics and mechanical tricks to get particles to touch their fibers. First, many spider webs are better than one. Unlike strainers, where stacking many identical ones doesn't improve the filtering at all, more layers of sticky fibers means more chances for particles to get stuck. And how likely particles are to hit or miss a fiber depends in large part on their size. Airborne particles larger than 1/1000th of a millimeter basically travel in straight lines because of their inertia. And because there are so many layers of fibers, their straight line paths are essentially guaranteed to hit a fiber and stick. Airborne particles that are really small are so light that collisions with air molecules literally bounce them around, so they move in a random zigzag pattern known as Brownian motion. This zigzagging also makes it super likely that a particle will bump into a fiber and get stuck. Particles of in-between sizes are the hardest to filter. That's because they don't travel in straight lines, and they also don't bounce around randomly. Instead, they're carried along with the air as it flows around fibers, meaning they're likely to get carried past fibers and sneak through even a mask with many layers. But N95 masks have a final trick up their sleeve. They can attract particles of all sizes to them using an electric field. In the presence of an electric field, even neutral particles develop an internal electrical imbalance which attracts them to the source of the field. This is why neutrally charged styrofoam sticks to a cat whose fur has been charged with static electricity. But unlike a cat's fur, an N95 mask's electric field isn't just ordinary static electricity. The fibers are like permanent magnets, but for electricity, electrets. Just like you can permanently magnetize a piece of iron by putting it in a strong enough magnetic field, you can electritize a piece of plastic to give it a permanent electric field. By electritizing the fibers in an N95 mask, they gain a long-lasting ability to attract particles, which means they capture about 10 times as many particles as regular fibers. And this is, after all, the point of an N95 mask, to filter out particles from the air, and they do it cleverly. By taking advantage of the molecular scale stickiness of matter, using many layers of fibers that catch straight moving large particles as well as zigzagging small particles, and having an electric field that attracts all particles, you get a mask, not a strainer, that's really good at trapping both large and small airborne particles, and does a reasonably good job at filtering out middle-sized airborne particles. Precisely what fraction of those sneaky medium-sized particles get blocked gives you the number of the mask. If at least 95% of those particles are filtered out, then the mask is rated N95. Okay, caveats.
Great, thank you for that, Gavin.
Get back to where we were here. Sorry.
All right, and so are there any questions about that? I hope that helped make sense because it comes up quite a bit. Aren't these particles just too tiny to be stopped by filters? And the answer is no, they're not. The filters actually capture them better than the 0.3 micrometer particles that define the HEPA. So I'll turn it back over to Gavin for the last section.
Sorry about that. So, thank you, Bruce. Yeah, no, I'm glad we got to show that video. I think it's a good one, and it does go into some caveats that we're not going to show today, where I think a lot of folks know about the importance of, well-fitting masks and other things like that. And we went a little bit longer than our practice run here, so I'm going to go through this last section really quickly. This was just it's pretty self-explanatory, and I think folks are going to have access to this after, and this is just we want to highlight some resources that are out there if you want to keep learning more. So this is what our LCOSH Nano inventory website looks like. I just want to highlight here that aside from the products and the information about the products, there's also a news and related info section. And also to mention that this is updated, usually Sarah on our team updates this weekly, not always new articles, but usually new products every week. We're constantly adding to it. So this is a living website. CPWR also has toolbox talks on a number of topics, including nano. We've got about 10 on nano. I've got the link here, and they're available in English and Spanish. And we also have a hazard alert card that talks about, what you should be doing, learn about the nanomaterials used in your trade. Where can you find them? What types of applications? Like we talked about, controlling the dust. And if that's not working, going lower down the hierarchy to PPE and wearing a respirator. And then there's some more information about risks and current regulations. This is also available in Spanish on our website. And NIOSH, they've done a great job. And as I think I said earlier, they have a whole research center devoted to this topic, looking not just at construction, but a lot of different industries. And we're fortunate to work on the construction, but it's a great place to go. They got tons of information, recommendations, guidance, and news. And finally, I don't have myself included here. Other folks on our team are a little better looking here. So, but CPWR's Nano team is at your disposal. We've got a great group. Feel free to reach out with us to us for questions. We've also worked with other unions to help them integrate this material into training, and we would be happy if anybody wants to work with us on that. We would be happy to work with you. And so thank you very much. That's the end of our presentation. I hope we've still got some time here for questions, and we've got our contact information please do reach out if you're interested, or if there's anything we can do to help. So with that, I'll stop sharing here, and I will kick it back to Lily. Thank you.
Thank you, Dr. Bruce Lippy and Gavin West. That was a great presentation. I absolutely love that video on that N95 mask and with the cat. That's kind of nice. That's great information. I want to just say again, thank you. And I want to open up the room for any questions that anyone might have. Dave, I know that before we got on, we had a little bit of a question. I think it'd be really good to share with everybody here. Do you mind asking it, Dave or Dan? Whichever one I forgot who it was.
Yeah, so one of the questions I had earlier was, is there currently any ASCOM symbols or easily identifiable means for the members to notice that there is nanomaterials in the products that they may be using?
I can take that. And the answer, Dan, is no. They're not in this country. Are there any requirements at all, except that there is hope on the horizon. I kind of alluded to that. OSHA in the new update to make sure we're using the global harmonization system properly will now require particle sizes to be listed on the safety data sheet. So then you can say, wow, this particle is in the 1 to 100 nanometer range. So that's going to be a major change, a good one. But there's no symbol that they've created some, just in some rough guidance, but it never really made it anywhere in this country that you would see that. Gavin, do you want to add something?
Sure, yeah. No, I think, and to add on to that a lot of times I think this might hopefully come out in the presentation, is that information is missing from the safety data sheets. And when we're documenting these claims about nanomaterials, we often find it elsewhere, in the advertising materials for it, or maybe in the technical data sheet on the website. And yeah, I helped. I participated in that rulemaking process when OSHA was seeking public comments, gave testimony, written comments on behalf of NAB2. Folks from NIOSH also weighed in on the importance of it, that we should be, communicating these hazards better to workers. And one other thing I'll mention is that there are things out there. Some folks are doing this voluntarily. There's something out there called health product declarations, which is kind of like a safety data sheet. And some companies are using these. And it's like a safety data sheet, but they try to be more transparent. And on those, there's actually a field where for the ingredients listed, they'll say yes or no. Is it in the nano form? Is it nanoscale?
Go ahead.
I was just going to say, and we'll see when this change to the HASCOM standard comes out. Hopefully that does happen, and I'm not sure when we'll see it, but it will be an important change.
There's also a standard. The International Standards Organization has a consensus standard they've had out since 2012 about how to write a good safety data sheet for nanomaterials. I chaired the committee for a while to try to update that, but it's a really good guidance, and it can be purchased from the ISO website. And if manufacturers really want to do a good job, it's out there how to do it.
Great.
Thank you.
Mm-hmm.
Thank you. I had a question. How long has nanotechnology has it been out? I mean, I know you guys started about 10 years ago, heavy dive into it, but how long has it really been out in the market?
So in general, not specific to, say, construction products, but just for general industries in general. In the early 2000s is the point when engineered nanomaterials started to be commercialized. So there was leading up to that were a lot of advancements in microscopy or manufacturing capabilities, and it's really exploded from there. And there's almost nearly infinite possibilities of the different types of nanomaterials that you can engineer and produce now. So there's new ones being discovered, invented, created all the time, and it really kind of changes our old notion of the periodic table of elements, and here are chemicals. We can really play with matter in a different way now. But so it's been, at least a couple decades since it's been around. We started tracking, construction sometime after 2010. And it's, been slowly building up since then. But that's a good question. I see we do have some hands up from participants there. A couple of people have hands raised too.
I do have a question that came in. Have there been any studies about nanoparticles absorbing into the skin from materials such as thin sets and grout?
That's a great question. And I don't know of any that have specifically looked at those materials. But there have been studies of dermal exposures and penetrating through the skin, and there's mixed results on that. So some have shown, metal particles can penetrate through skin at occupationally relevant doses, but others have found not so much. And the model that they typically use in those, so like I said, it's hard to do these studies on humans, so they use pig skin typically in these studies, which is the closest to human skin. But there is some indication that in some cases, that you can have that dermal exposure where it gets through the skin. I think another thing that we point out, in some of our other presentations when we do get into that is, if the skin is intact, right? So, there's a greater chance of exposure if the skin is compromised. So, if you're working with anything like any kinds of solvents or degreasers, or if you're just kind of working with rough materials and you've got cuts or things. So that's pretty common among the trades where, you might be working with things where the skin can cause the skin to be damaged and increase the risk of exposure. Bruce, if you want to add
No,
on?
that's a good point. Skin is definitely a potential route of entry for nanoparticles.
But the other thing I would say is most of the studies have focused on inhalation. That's been the most studied route of exposure. Not as many studies on dermal, but it is something that you shouldn't neglect that.
I just wanted to make a comment that I see the parallel of the nanomaterials that kind of coincides with the problems that we had with asbestos, because at the time when asbestos came out, the technology of using asbestos, how they were putting it in all materials, it had a benefit, obviously, because they were putting it in everything. They were putting it in, they were putting it in metal to make it more pliable. They were putting it in adhesives, et cetera, et cetera. And it was only till we started to discover that the adverse effects of it afterwards was how it was affecting people. And I think this kind of correlates with how we learned from asbestos, but I think you guys are doing an exceptional job of getting it way ahead of the curve before there's the unforeseen knowns and people are getting very, very sick. So kudos to your team for, getting well ahead of the problem and doing the investigation well before people start getting sick. We can do things like this to educate people. So, thank you for the work that you do on behalf of workers.
Well, thanks, Dave. I would also say thanks to NIOSH. They have funded us now going into our 10th year, and it's been a very close partnership. As Gavin said, they come to our site and they take their own measurements. They lend us equipment. And they're looking at the area we can't, which is the toxicity part, which is really very critical. Thank you, but it's a great partnership we have.
Thank
Absolutely.
you all. Thank you again from us. Thank you for participating. We're coming up on the hour. Good thing we don't have any other questions. We just like to again extend my gratitude for coming on and giving us this great presentation, and helping our members and ourselves. I mean, I speak for myself, and understanding nanotechnology and nanomaterials. Again, great presentation. We will share your slides if you are willing to share them with our members and anybody that's on this chat and on our website. You know, I think this information is great. Again, thank you all.
Certainly.
Any closing comments?
One
Yes,
for
thank-
me is that there are paper copies if your members and trainers want to work. We have the hazard alert cards, we have the toolbox talks, we can provide them in Spanish and English and in paper if necessary.
Great, thank you.
Quantities, yeah.
Yeah, no, that's a good point, Bruce. Thank you very much. It was great to be here and
Yes, always
happy to
enjoy
do
this.
this. Yeah.
And thank you everyone who joined the call today. Again, you can find this webinar on our website, recorded version of it, and we'll have the slides up there as well in case you guys want that too. And thank you all. Have a great evening.
Good night, everyone.
Thanks. Have a good Labor Day weekend, everybody.
Yeah, that's right. Enjoy.